Okay, I think it's showtime. So welcome to this episode of Insider's Guide to the Galaxy. I'm one of your hosts, Charles. I'm in the background today running things, and Chris Vaughan, our expert of the skies, is here to tell about the inner planets today. Take it away, Chris.
Well, looking at thanks, Charles, and hi everybody. Looking at the events in the sky, I suddenly at some point realized a while back that tonight was the greatest elongation of Mercury, and it's actually the best evening apparition of the year to see Mercury. So hopefully folks have already been aware of that and have taken a look. But if not, then no better time to kind of highlight that fact and let people get out there to this evening if it's clear, or the next few nights, and take a look at Mercury. And of course, at the same time, we've got Venus gleaming up there in the western sky along with Mercury. So hey, let's do an inner planet special. So I spent some time doing some research, boning up a little bit about some fun facts about the two planets. So I mean, we don't have to worry too much about how to find them, although I will mention some ways to find Mercury, but Venus is not going to need, you're not going to need really any help finding that. So I thought I'd sprinkle in some of the other interesting science to do with the planets themselves and their orbits and some of the weird behaviors that they bring up. So let's just start by sharing some interesting images here, just to sort of set the scene. Here we go. So you should be able to see here the inner solar model of the inner solar system, of course, with the sun in the center, Mercury, Venus, Earth, and Mars, the four innermost planets. And I'll see if I can get the sun centered here and just swing this around. Just wanted to show, let's see, let's do this, tilt this upright. So from our vantage point on the Earth, you know, we get the planets doing all their different things. So sometimes they pass close to the sun at conjunction. If they're an outer planet, farther from the sun than we are, they can actually either be, you know, next to the sun on the far side of the solar system, or they can be opposite the sun in the sky so that they rise at sunset and set at sunrise. But the two inner planets, Mercury and Venus, are a little different. So they're never opposite the sun in the sky. They're always between us and the sun. So for us, we see them passing close to the sun at two different times, once when they're between us and the sun, and another time when they're on the far side of the solar system from us. So they have two sorts of conjunctions. The one where they're between us and the sun, we call that an inferior conjunction. And then the one when they're on the far side, we call that a superior conjunction. So we'll mention that a few more times as we go here. And then they never get behind us from the point of view of the sun. They're always somewhere between us and the sun, but they can stretch to the east and the west of the sun in the sky and produce something called an elongation. So this is a diagram, kind of a cartoonish image of that scenario. So here we are sitting on the Earth with the sun, you know, beyond, and then as the planets swing in their orbits around the sun, there are times when they're in line with the sun, as I said, and then there are times where they're kind of on the outer turn of their orbits from our perspective. And we call these events greatest elongations. So when the elongation happens in the evening, then the planet lingers in the sky once the sun is set, because it is east of the sun in the sky. So we call that the eastern elongation. And then when the planet is up in the morning sky, it rises before the sun because it's west of the sun, and we call that a western elongation. And you can see here that we've got a case in this particular model that Venus was close to greatest eastern elongation, and around the same time, Mercury was in the morning sky at greatest western elongation. So that's kind of a setting the stage here, as you can see. Now, one of the cool things that happen as a result of all this, though, is that because the Venus and Mercury can theoretically pass between the Earth and the sun, sometimes they actually cross the disk of the sun, producing what's called a transit. So, you know, a total solar eclipse is a transit of the moon across the sun, but the moon being so big, it covers the entire disk of the sun. Mercury and Venus being so tiny, all we get in their cases is we get these little black dots crossing the disk of the sun for a period of time every now and again. Now, I'll go into a little bit of detail on how some of these work. So the Mercury transits, they actually happen about 13 times a century. So, and it only happens during May and November, because those are the times of the year when the Earth is sort of sitting on the with the node, the descending node or the ascending node, the point where the orbit of Mercury crosses the plane of the solar system, or make that geometry possible. Now, Mercury has this strange orbit. I'll come back to it in a little bit, but it's very eccentric, and it varies in its speed as it orbits the sun quite a bit. So as a result of that, we get about twice as many November events than we do of the May events. The last one that we could see was on November 11th, 2019. It was cloudy for everybody that I know. I think Alan Dyer had a picture of it. I don't have a link to it on me at the moment, but I think he's got a composite picture where he showed the dot of Mercury transiting much of the sun's disk. If you sort of search his website, you can pick that up. The next one that's going to happen will be on November 13th of 2032. That'll be a morning one, but it's only going to be visible sort of from Europe and Africa over across Asia to Thailand, sort of longitude. So we're not going to get that one, that Mercury transit from here. But that's fine, because the next Venus one is going to be a long time coming. So Venus transits are a lot less frequent. They're easier to see because the dot of Venus is much bigger than the dot of Mercury. And they are actually split about equally between the date of June 7th and the date of December 22nd, within a day or so of those two dates. Again, that's because the Earth is in a line with Venus's descending and ascending nodes. So Venus transits occur in pairs separated by more than a century, so about 105 years and 121 years. And the second in the set occurs 2.5 days short of 8 years later from the first one. And that's because there's actually an orbital resonance between the orbit of Venus and the orbit of Earth that causes Venus's position in the sky to repeat almost exactly every year. And so if it was in front of the sun on the one date, then 8 years later, minus 2.5 days, it's going to be in front of the sun again. That's sort of the way that works. The last pair of Venus transits were on June 8th, 2004 and June 6th, 2012. I definitely saw the second of the two. Did you see them, Charles?
No, I didn't get a chance to see that.
The next one is going to be a long time from now, December 11th, 2117. Again, not visible from Canada, though. It's going to be sort of in the Middle East to Hawaii, sort of the other hemisphere of the Earth. The next one after that, the 8 years following that, the December 8th, 2125. Mark your calendar. That one will be visible from Canada. So that's a good one to wait for. That one's actually going to be a short duration one, because depending on whether the planet crosses the sun's disk centrally or more towards one of the, polar hemispheres, then the chord can be longer or shorter across the disk of the sun. So the one in 2025 will be a relatively short transit because it'll sort of be crossing.
Chris, we have a question.
Yeah.
Which might be easiest to answer because you've got it going right now. They can see objects moving beyond Mars there. Can you tell them what that is?
Oh, all of these little green dots, these are the asteroid belt. Yeah, sorry, should have explained. I don't know if you can see them. Yeah, so we haven't picked up the orbit of Jupiter. If I do this, I can go down here to Jupiter and click on its orbit. And there you can see that the asteroids are in that zone between Mars's orbit and Jupiter's orbit. Last comment about the transits though, is like a solar eclipse, you must wear proper solar filters to witness the event, or have proper, solar filters for your telescopes if you're going to following them through the eyepiece. Very important. Now, the transits of Venus have been used by early astronomers to actually estimate or calculate or measure the distance between the Earth and the sun by using various observers on the Earth observing the event and comparing the times that the various observers saw the event happen. Allows us to create a triangle and use some trigonometry to calculate the Earth-Sun distance. And Charles, I don't know if you put in the chat those two links to Fred Espenak's eclipse
Yes, I have.
information.
Just
Yeah,
looking
he's got lists of the various transits historically and in the future as well, so you can pick those up. All right, so let's put this away for a second, and I'm going to show you a little bit about the planet itself. I'll actually bring this up and just have this ready to go. Here we go. Let's let everybody sort of stare at these planet facts while I tell you a little bit more about Mercury and Venus in history. So the earliest known sort of reference to Mercury in human history, recorded history, were inscriptions by the Babylonians on their Mulapin tablets from about 1000 BC. It was mentioned in works by Ptolemy around 100 to 170 AD, current era. The Greeks, they named the planet for their god Hermes, the fleet-footed herald of the gods. The Romans used their own version of the same deity, Mercurius, so that's where we get the name from. The ancient Chinese, they called it the hour star. Later on, it became Shuixing, which is translated as the water star. So the Chinese took the 5 bright naked eye planets and assigned them to the 5 elements of their philosophy, earth, water, wood, and so on.
metal, air.
Yeah, Charles will be an expert on that. Interestingly, the Maya people of Central America, they seem to have envisioned or assigned Mercury to an owl or maybe a set of owls. And that may be because of the planet, rising up from the horizon and then diving back down. The owl would have been the messenger to the underworld. So this sort of owl coming up and heading back down. I thought that was really fascinating. In terms of, our modern day scientific exploration of Mercury, that really began by Galileo back in 1610 when he first, aimed his telescope at the planet and started to observe that it had or exhibited phases. So it wasn't just a simple disk, it showed phases as it varied its angle from the sun. In 1631, the French natural philosopher Pierre Gassendi, he actually observed a transit of Mercury that had previously been predicted by Johannes Kepler. In 1661, a Polish astronomer, Johannes Hevelius, he observed another transit of Mercury and published his study. He's got a book that you can look up and see all his studies. And I think I've even got a picture here of the phases that he sketched. There we go.
I put the link in if people want to.
Yeah, that's a plate from his book showing the phases that he saw. I thought that was neat. So obviously, once people started to see all these different phases of the planet, that was really, the evidence that it was orbiting the sun and not using the geocentric model of the solar system. Eventually, people started to see if they could see, surface features on the planet as telescopes got better in the 19th and early 20th century. So they were starting to make maps. A Greek astronomer, Eugenios Antoniadi, published a book in 1934 that included some maps and his observations of the planet's surface. Charles can share the link. I'll just open it up so you can see the picture of the map he made here. Bring this up and come down here. Here we go. Now this is, this map didn't turn out to be terribly accurate. Of course, it's a little bit akin to, Lowell's Canal on Mars maps that he sketched back in the day. But, he certainly had some of the main features pinned down properly. And we still, the features that we can correlate back to his map, we still call them the same names that he originated back in the day. Eventually, we started getting better pictures of the planet itself. In around the year 2000, using the 1.8 meter Hale telescope at Mount Wilson, they used the lucky imaging technique where they take a lot of frames of the planet and picked out the clear ones, and they started to resolve the features on the planet. By then, of course, we actually had some space missions do some flybys of the planet, so we did have some pretty good images of the planet close up. But some of those were not orbiters, so they didn't necessarily get to map the entire planet. In fact, the Arecibo radio telescope was also able to bounce, radio signals off Mercury and mapped it with a 5-kilometer resolution, which is pretty good. And it actually picked up some hints of those, deep craters that are in permanent shadow at the poles of Mercury that may contain water ice. So let's switch over to Venus for a minute. So like Mercury, Venus appears in the morning and in the evening when it's sufficiently far from the sun. Unlike Mercury's appearances, which tend to be relatively brief, Venus's appearances are much more lengthy, and also it disappears for longer stretches of time. So there was some confusion early on as to whether, the bright evening star was the same object as the bright morning star you'd see at a different time of the year. So that there was that sort of evening star, morning star nickname is still used by lots of people today. There is evidence that the ancient Sumerians knew that it was a single object, though. The Babylonians, they named it Ninciana, which translates into something close to the divine lady, the illuminator of heaven. The ancient Chinese, again, they had different names for Venus, whether it was appearing in the morning or in the evening. And later on, it became their Jinqing, which is their golden planet or metal, the metal element of the 5 elements. Now, the Greeks, they again distinguished between the morning and evening. They used the term or the name phosphorus when it was in the morning sky, and Hesperus when it was the evening sky. The Romans kind of emulated that by translating those names into the Latin versions, which would be Lucifer and Vesper. Now, Phosphorus and Hesper in Greek mythology were actually half brothers. They were the sons of the goddess of dawn, Eos, and those names roughly translate to light bringer and brilliant one. So those are sort of fitting for Venus. Now, again, we've got reports that astronomers way back in the 11th and 12th centuries may have been able to detect transits of Venus and Mercury as well across the sun, but some of their reported dates don't match up to the ones we can simulate, in modern astronomy apps. So maybe they were seeing sunspots or something else that were transiting the sun. Things really kicked into gear, though, of course, again with Galileo back in 1610, when he started to observe Venus. And he actually started around September of 1610. He had looked at Jupiter and Jupiter's moons earlier that year in January. But by the fall, he was, looking at everything with that telescope. So once Venus appeared in the evening sky, he started following that. And over the next number of months, he was able to pick up its phases. And don't think I have a link here handy, but if you do go on and do a Google search for Galileo and Venus, you can pick up his hand drawings of the various phases. And that really helped him, again, postulate that the sun was in the center of everything and that Venus was orbiting the planet. There was a Venus transit on December 4th of 1639, but that was kind of before the switch to between the Julian and Gregorian calendars. So it really was, if you use Stellarium to simulate it, you're going to use December 4th, but it was actually November 24th in the records because of that 10-day difference. That transit had been predicted by Jeremiah Horrocks, and he observed it, and William Crabtree observed it, each of their own homes. Now, the fact that Venus was shrouded with these opaque clouds, that was sort of predicted or assumed as early as 1698, when Christian Huygens couldn't make out any features on the planet, despite a lot of study and telescopic observation of it. So that sort of gave him a sense that there was no variation in albedo, that probably it was uniformly smooth or uniformly shrouded. That proof was sort of extended or improved upon by Russian polymath Mikhail Lomonosov, when he observed the ingress and the egress of the planet Venus during a transit. And when the planet was close to or just approaching the disk of the sun, the backlit planet had a halo around it, much more than you'd expect by the mere illumination of a solid ball. So that extra long horns on the crescent, or maybe a ring of illumination all around the planet, was suggesting that it had an atmosphere and it was backlit, and that was giving it a little bit of a halo. So that was further proof of it. Later on in the 20th century, we started doing things like taking the spectra of Venus, bouncing radar off it again, using ultraviolet, looking at it in the ultraviolet, which began to sort of reveal some details about the planet's rotation. And again, the Arecibo telescope was used to probe the surface and note some large reflective regions, and that actually allowed us to kind of note when they were visible and give us a sense of how the planet's rotation was working. All the sort of surface locations on Venus are named after female deities or female historical mythological women. The only exceptions to those are the features that were seen by Arecibo and some of the early explorers that named. There's a mountain range named after James Clerk Maxwell called the Maxwell Montes, but there's really only a few exceptions to the feminine rule there. Now, a trip to Venus is the easiest one to make from Earth because the delta V between the two planets is less than any other planet. It's actually quite hard to get to Mercury from Earth. You need to do a lot of gravitational assist to slow the spacecraft down to get it down to Mercury's point. But Venus is a lot easier. So lots of spacecraft has been sent to Venus, particularly by the USA and by Russia. So the Mariner 2 mission flew by in 1962, which was the first successful interplanetary mission. And then the Soviet Venera craft landed, descended the atmosphere in 1967 for the first time and started measuring the chemistry, the temperature, and the pressure, things like that. That spacecraft was not robust enough to make it all the way to the ground, but the pressure was so high. The first landing by a spacecraft on another planet was the Venera 7 mission that landed on Venus in December of 1970. And pictures of the surface began to be revealed by the Veneras 9 through 14 spacecraft around 1982. There was an ESA, European Space Agency Venus mission called Venus Express. It performed orbits of Venus from April of 2005 until December of 2014. And it discovered that Venus's atmosphere is highly variable in both pressure and temperature with altitude above the planet, and that Venus has evidence for recent volcanism, although I don't know that we've seen any volcanoes in action up to now. There is a Japanese mission called Akatsuki that's been in orbit for quite some time, and there are a few more missions planned. I'll stop for a second, see if anybody had any questions on anything. I know I'm going a little fast.
Yes, we have two in the questions. One is from Human, who is asking why the rotation period of Venus is negative.
So glad you asked. We'll go to that in a second. What's the other question?
The other question is from Atul Dave, and was it even before our moon?
Was it backwards before the moon or formed before the moon?
I'm not really sure. Perhaps he could
Okay.
type another addition to the question there. Also, Anita has her hand up, so I'm going to allow her to talk. There you go, Anita. She needs to unmute herself.
No, she's shy.
She's shy. Okay. Okay, well, we'll come back to that and see if
Yeah, if I don't answer it, just ask me again.
He said, was the Venus trip before we got to the moon? That's what he's asking. Did we land
Venus trip before we got to the moon? Let's see, what did I say? Around the same time. Yeah, 1970.
Mm-hmm.
Yeah, there's been a mix. There's been a mix of planetary exploration and then human crewed spacecraft to the moon, that sort of thing. Yeah, that's a good question. Thanks for
Okay.
asking that.
I'll find the exact date.
Cool. Yeah, some of them are in the notes. I'm sort of avoiding giving you every single day and date, but that's okay. All right, so let's look a little bit about the solar system facts. We've got Earth. You know, Earth is sort of the measuring stick we're going to use here. So we're going to sort of compare things to Earth, year, day, diameter, and so on. And then you've got Mercury and Venus sitting above them in the table here. So, you know, we've got Venus being the second closest planet to the sun. It's actually only, let's see here, the 0.95. It's only a few hundred kilometers in diameter, smaller than the Earth. So it's literally a twin, you know, a twin sister to us. But interestingly, the planet itself is only about 80% as massive. So that means its bulk composition is a little bit lighter than the Earth is. So it's got a bulk density of 5.2 grams per cubic centimeter. Now, the big deal about Venus is its atmosphere. Its atmosphere is something like 96.5% carbon dioxide and about 3.5% nitrogen. And then there's some sulfur dioxide and things like that in the mix in lesser amounts. The pressure on the surface of Venus is about 50 times Earth's surface pressure, or about 93 bars. The average surface temperature is about 464 degrees centigrade Celsius, which is even hotter than Mercury. The uppermost cloud layers of the planet are rich in sulfuric acid, and the clouds reflect with high albedo, about 90% of the sunlight, 60 to 90%, I've seen different numbers, making the planet very bright in the sky, but also making the ground level dark because the sunlight can't penetrate to reach the surface too easily, invisible wavelengths. Interestingly enough, the thick atmosphere of Venus has actually caused it to be relatively uniform in temperature around the globe. So unlike the Earth, where we've got various, you know, temperature differences between our equator and our polar regions, Venus is almost uniform in temperature, regardless of latitude, and even doesn't even matter if you're on the lit side or the dark side. So it's very uniform throughout. The way you get to a different temperature in Venus is you've got to climb a mountain. You want to cool down a little bit, you just basically need to find a hill or a mountain and climb higher. It'll get a little cooler there, but you can't go to the North Pole and get cooled down. The axial tilt of Earth is 23.5 degrees. Now, I don't have all these columns in the table, but you know, the 23.5 degree tilt of the Earth gives us our seasons because of the way our northern and southern poles of rotation tip towards and away from the sun throughout our year. Venus's tilt, as alluded to by the question earlier, is 177.36 degrees, which is almost 180. So that causes the planet to roll the other way. So I'm going to show you a simulated view here where that's happening. Let's do this. Let this load up. Here we go. Venus orbit from the sun. So one of the cool things you can do, you can't do this necessarily in Stellarium, but I'm using a program called Starry Night. And what I've done is I've actually parked myself at the center of the sun, and I'm looking out into the solar system, and I've just zoomed in on Venus. And you can see the red line here is Venus's equator. You can see the two sticks at the top and the bottom. The yellow stick is the North Pole. So it should be pointing up, but it's pointing down because the planet is tipped almost on its head over heels.
One of their people search words asking, what is orbital inclination?
Orbital inclination is so the whole solar system is set up roughly in the same plane around the sun. And most of the planets' orbits themselves are near that average. The average is actually called the invariable plane. Most of the planets' orbits are relatively close to that. Venus's is I think only about 3 degrees different from that, slight tip of the plane. Mercury's is more like 7 degrees, so it's quite a bit. We'll come back to why that's important for observing Mercury in a little bit. Yeah. Yeah, so what was I saying? Oh yes, the planet has no tilt, virtually no tilt of its axis, except that it's almost exactly upside down. So it doesn't really experience seasons the way we would, but it is rolling reverse to what all the other planets in the solar system are doing. Now, that means that if you could see the sun, which you can't, it would rise in the west and set in the east, along with everything else, which is backwards from what we're used to. Now, we don't know whether Venus formed that way, or whether it maybe got impacted by something that tipped it early on in the process. There's also a possibility that it's a torque induced by its interaction with the sun and with its atmosphere that has actually sort of put a force on it that has actually caused it to tip upside down. That's one of the reasons, you know, we want to study it in more detail to learn some more of these details. So I know you wanted this, the questioner wanted me to answer why it's backwards. I'm not sure we really actually know, but it is bizarre. It's weird. A couple more things that are cool about, let me just open up and show you the surface of the planet. There we go. So we can actually peer through Venus's atmosphere with a radar. So the Magellan spacecraft was able to look through the clouds and make a map using radar, the various features. And this Starry Night program lets me show you that globe. And I can also show you the topographic features. And I've got some labels of some of the major features indicated here. You can see there's Aphrodite, there's Ishtar, and you can see that there's those Maxwell Mountains near the top. So the pinkish areas are the high elevation mountain regions, and the blues and greens would be the basins or the low lying. Now, as I said, you know, Venus is almost the same size as Earth. What's interesting is that it's possible that Venus had more water initially and that it lost its water over time. But the lack of water has actually made its crust a lot stiffer. So one of the things that Earth does is it's got plate tectonics, and we think that a lot of the mechanism for plate tectonics is facilitated by a lot of sort of water and flexibility that lets those plates sort of bend and dive under one another. We think Venus is very dry, relatively dry in that sense, so it doesn't have any plate tectonics. And that may actually make heat not able to escape the planet as readily as it can here on Earth. And so that means that the surface, the upper level of the mantle on Venus isn't cool compared to the deeper part of the mantle, the way it is on Earth, because there's no convection, there's no turnover of the heat in the interior of the planet. And we think that as a result, it has actually kind of stiffened or stopped the internal dynamics or dynamo of the planet, and therefore produced no magnetic field from internal the way the Earth has. Venus does have a bit of magnetism associated with it because of its interaction with the solar wind streaming past it. So there's a bit of magnetism from that, but no internal intrinsic magnetic field the way we have.
As long as you've got that image up, Chris, someone's asked, what is the maximum difference between high and low points on Venus?
The numerical difference, I'm not too sure of the height difference, but I'm sure we could do a Google search for the elevation change. I'm not sure what the number is. Yeah. Now, Mercury's orbit, not only is it tipped with respect to the solar system, it's also quite elliptical compared to the other planets, whereas Venus's orbit is almost perfectly a circle. So that gives it a nearly perfectly circular radius of 108 million kilometers, or about 0.72 of an astronomical unit. It orbits the sun every 224.7 days. And if you do the arithmetic, you can see that Earth does 8 orbits or 8 years in the time it takes Venus to do 13 years. And that synchronicity produces that idea of Venus reoccurring in the same parts of the sky on an 8-year cycle. Now, because of this, because Venus is not only rotating backwards, but it's also rotating very, very slowly compared to the Earth's rotation. Not sure if that's evident from this picture here, but if I were to put this to real time and compare you to the Earth, you'd see Venus is barely turning compared to the Earth's rotation. It completes a solar day every 116, almost 117 Earth days. And so its Venusian year only contains 1.92 Venusian days, as opposed to Earth's 365 days in a year. The other effect of that slow rotation, we think, is to keep the planet very spherical. So it's very, very round compared to the other planets. So that may have contributed to the torque and causing it to flip over. Now, back to Venus for a second. I mean, Mercury for a second here. So Mercury obviously is the smallest planet in the solar system. It's actually smaller than both Ganymede and Titan, the 2 moons of Jupiter and Saturn. Its bulk density is about 5.43, which is almost identical to Earth's. But so it's much more massive than those icy moons of Jupiter and Saturn. Mercury is composed of about 70% metallic materials or minerals and 30% silicate, which is a lot different from the balance that Earth has. So that means, if you think about it, it's got a much bigger, as a percentage, core, heavy iron core in its center. That may have happened for a few different reasons. So it could have been that before Mercury formed, the solar wind started shining and blew away the lighter volatile elements. And so it had less of that to bake the cake with. It had more heavy elements, but fewer of the lighter silicate if it formed after the sun began to shine. Or it's possible that the proximity of the sun has actually sandblasted its outer surface and stripped away its outer shell, leaving an anomalously large core. So there's a few different theories around that. Obviously, Mercury resembles the moon's surface. Let me just switch over to Mercury here. Where's my Mercury? Here we go. So at first glance, Mercury resembles the moon. You don't have the big dark maria that you tend to have that we see on the moon. Again, there is no plate tectonics operating on Mercury, but there might be some volcanic activity. The orbital eccentricity is about 0.21, so its distance from the sun ranges from 0.31 to 0.47 astronomical units. And that actually produces about 17 times the tidal force that Mercury experiences than the Earth would from the sun. It also gives it a very highly variable orbital speed. It's about 50% faster at perihelion than it is at aphelion. It has a 3.2 or 3 to 2 spin orbit resonance with the sun, mainly due to that highly elliptical orbit. And that gives it 1 solar day every 2 Mercurian years. So it too has been very, very slowed in its rotation. And what's neat, so if I'm going to actually speed this up. I don't know if you noticed this, but I'll do this one more time. I'll rerun this file. So what we're doing is we're watching Mercury from the sun over a period of time. You can see the red arc up down is the prime meridian. On Earth, that would be Greenwich, England. And then the horizontal red line is the equator. You can see Mercury's getting big now. And if you watch for a second, you can see it stop rotating. And now it's starting to shrink. And now it's resuming rotating. That's because there's a period of time where the Mercury's speed of orbit counteracts its rotation effect. So the sun hangs over a spot on the planet for a long period of time, and it heats up that spot on the planet's equator. And so there are actually 2 spots where that happens. And those spots have been actually assigned. So here's the second one. Those spots have been assigned to be the prime meridian and the anti-prime meridian of the planet using for the planet's coordinate system. So let me just bring that. I'll start this again so you can see this again.
While you're doing that, James is asking, do the long days affect the overall temperature? Does the nighttime side cool down significantly?
Yes, there's actually a big difference between the day side and the night side on Mercury. Definitely.
And
I don't have
someone's
the.
asking, what are the blue streaks that appear quickly in the picture?
Oh, those are actually the. Let me just get rid of them. Those are actually the constellation lines. Let me turn them off. Let's do this. Forgot to save that. There we go. That won't happen now. Yeah. Now, when Mariner 10 flew by back in the 70s, I guess, it skimmed only 700 kilometers above the surface, getting to some nice close-up views of the planet. But it only did a one-time flyby, and at that time, half the planet was in shadow, right? Half towards the sun, half away from the sun. And so the hot spot at that time of that flyby was actually in darkness. So astronomers were not able to pinpoint a crater that they could then use later to say this is going to be the 00 coordinate. So if you noticed on this file, I'll do it again. You can see that there's a place labeled Huncal. So that there's a crater named Huncal, which was visible when the flyby happened, and it happens to be at 20 degrees west of the prime meridian. So they use that as their kind of 20-degree mark, and then they measured over and put the 0 mark where the two red lines intersect. All right, let's see what else is cool about it. So we have the 2 hot spots. We then have 2 cool spots at 90 degrees to both of those. And the other neat thing is that you may have heard about the precession of the perihelion, and that causes the disk or the plane that Mercury orbits in to gradually precess around the sun, and the predicted amount of that is about 42 or 43 arc seconds per century, different than what should have happened under Newtonian gravitational laws. And it turned out that Einstein's general theory of relativity was coming into play. The warping of space-time close to the sun, the mass of the sun, is actually causing Mercury's orbit to precess a little bit faster than it should be. That 43 number for Earth, that effect would amount to about 4. So this is about a tenth of that same effect. A couple missions that went to Mercury. We had Mariner 9 and Messenger, 2 spacecraft that have been to Mercury. Another one called Bepi Colombo is going to enter orbit in December of 2025. It's already on its way. So they've been investigating Mercury's geology, interior structure. They've detected the ice at the poles and the deep unshadowed, permanently shadowed craters in the poles, and some magnetism as well. And I think there's a map here. Let's see if I can open this map. You can put the link in the chat too, Charles, for the map. There we go. So the U.S. Geological Survey has a nice map with the locations of the planet labeled. Again, this is color coded according to elevation, so it's a topographic map. I can do that here as well. I can right click, surface image model, and let's see. No, I don't have a topographic map. It's okay. Okay, that's basically it for the planets. Let's sort of switch over now to observing the planets. Any questions though before I go?
There's one from Linda Neal saying, does Mercury change rotation? So I think you basically shown how it pauses there, or appears to.
No, the rotation doesn't vary inherently, but the apparent rotation would vary from the sun, because there are times where it's the same phenomenon that gives the moon its nodding and wobbling, the libration effect. What you were seeing there is libration of Mercury. There are times where it's moving faster. It's moving at the equal to the rate of its rotation. So it looks like it's it looks like it's standing still. But in truth, if you viewed it from afar, you'd see it constantly turning.
Okay,
If that makes sense.
Sorry, two other questions. One is, how does it compare to Earth's 26,000 years?
How does it compare to Earth's which?
26,000 years is the question. My dog is trying to answer that question.
Okay.
Jill Milborn is also saying, weren't the Russians the first to orbit Venus?
Could very well be. I'm not 100% sure. Yeah.
I'll check that.
Yeah, part of the reason for doing these topics is to get people to delve deeper and to find out more about them. Be a little bit inspired to dig a little deeper. So, yeah, by all means, let us know what other neat things you find out. All right, let's switch over to Stellarium here. See if we've got some fun stuff to show. Put this away. Put this away too. There we go. All right. So here we've got the tonight's sky around 8:30 p.m. local time. You can see we've got Venus and we've got Mercury. So Mercury has been climbing towards greatest elongation or away from the sun. So Mercury orbits the sun every 88 days. That's its sidereal period. It alternates between morning appearances and evening appearances, just like Venus does, but it tends to be much less delay between appearances. It never gets more than 28 degrees away from the sun. The minimum sort of elongation it'll do is about 17 degrees. And that planetary inclination to its orbit is the reason why it looks so far from the ecliptic. Let me just show you if you go into the markings section of Stellarium, you can bring up that invariable plane. Where is it here? Invariable plane. I think it's on here. There it is. So the sort of mauve line here would represent the average plane of everything that's orbiting they're orbiting the sun in the solar system, the average plane of the solar system. Earth's ecliptic, so Earth's orbit, would be the yellow line. So it's a little bit off of that average. And you can see that Venus is a little bit off of it, but Mercury's quite a bit off of it. And if I bring up Mercury's orbit here, which I can do this way, there we go. Then you can see that effect happening, and I'll just wind the time back a little bit so you can see that. So that inclination causes Mercury to wander north and south of the ecliptic by, up to 7 degrees, by quite a bit. And that means that there are times when, if the ecliptic is tilted, Mercury can still be above it, but there are times where it's tucked underneath it, which makes it extra hard to see. We'll come back to that in a second. The other cool thing is that, both Mercury and Venus vary their distance from the Earth. Venus gets to within about 41 million kilometers of the Earth, but on average, Mercury is the closest planet to every other planet in the solar system because it's near the sun and all the planets orbit the sun. So if you average up the distances between a planet and Mercury, it turns out to be on average the closest planet to any of them. Let's see. So the equality of an appearance by Mercury is dictated by how many degrees away from the sun it gets, or its greatest elongation number. When it does that, is it tucked below a tilted ecliptic, or is it sitting above, making it higher? The more above it is, in fact, the more that the planet is above the sun, then the longer it lingers after the sun sets. And that gives us a time for the planet to actually shine in a darkening sky. So that's why this evening will be great, because you can start to see Mercury, potentially around 8:30 p.m. And if you've got clear skies to the west, you could follow it down until the point where it's actually shining in a dark sky. By this point, it's going to be by close to 9 o'clock, Mercury will be about palm's width above the horizon, if you're looking for it. Okay. Nothing else in the neighborhood is as bright, except for Venus, obviously. So you shouldn't really have any problem getting distracted by any other objects that might fool you. So because of that sort of above and below the ecliptic factor, even a case where Mercury is not very elongated from the sun can still be a better than average appearance for it. So what you can do is look at the kind of upcoming appearances and pick the ones that you want to look at. So here, let me show you. I'm going to bring up a graph. Let's see here. I'm going to do this. Here we go. Open. I'm going to put on the screen a list of the upcoming appearances of Venus, of Mercury in the sky. So there's a set for 2023, including some that have passed, one that has passed, and then a couple in 2024. You've got the number of degrees away from the sun it will be. West means it's in the morning, and then east means it's in the evening. You've got the apparent brightness or magnitude of the planet. And then I've got the rating for Northern Hemisphere and Southern Hemisphere. So if you're viewing us from Canada today, just worry about this column. If you're viewing us from the Southern Hemisphere, you want to look at the last column. So you can see here this April 11th, tonight after sunset, 19.5 degrees, about magnitude 0, which is nice and healthy. This is an excellent apparition, about the best of the year for the evening time. If you go into September, we're going to get the best of the year in the morning time. So around the peak will be around September 22nd before dawn, only 18 degrees from the sun, but even a little bit brighter than tonight's. And this will be excellent. We've also got a couple of poor apparitions coming up in May and August, but they're going to be excellent if you're viewing it from the tropics or from the Southern Hemisphere. And then at the end of the year, we've got December 4th, a poor one for the north and a decently good one for the south. Another neat thing is on this graph is I've got the number of days since the previous appearance of the previous elongation. And you can see that it alternates between about 50 days and about 70 days. So 51.71, 48.73, and so on and so on. And that's because obviously we're viewing Mercury from a moving platform of the Earth, and also because Mercury's speed around the sun increases and decreases during its aphelion and perihelion. So these are great opportunities to take a look, and you want to make note of this. All right, hopefully everybody captured that.
Right here, Chris, because we got a bunch of things here. One is somebody saying, what is the time frame between first visibility and when it slips beyond the horizon?
Yeah, so it actually depends again on the angle of the ecliptic and whether it's actually approaching us or receding from us. But basically, you've got some instances where Mercury will take its time climbing and then rapidly drop, and other times where the reverse will happen. But this particular one, let's see, I'll just advance the dates here a little bit. So this is tonight. So you can see it's still going to be quite good. So here, as I said, here's tonight. So 12, 13, 14. You can see it's even improving for a few nights, and now it's starting to drop more significantly. So if you catch it on the next, say, 4 nights, you'll have plenty of good luck. After that, it's going to rapidly drop to the sunward. In advance of this, though, you've got quite a few days where it was nice and bright. Of course, the timing makes a bit of a difference here. So it does vary a little bit. I don't know if I had them in the notes which one was which. I do believe I did that for the Venus one, but I don't know if I did for the Mercury one. Do you happen to know, Charles?
Not right now. We had 2 other questions. One is, well, one's pointing out that Uranus is also tilted. Yes, it is. They're asking, is it tilted 90 degrees?
Yes.
Yes, it is. But somebody else is saying, when you were talking about Venus being flipped on its northern pole, sitting at the southern end, how are we defining the North Pole? I'm very new.
Great question. So scientists have decided that the sun rises in the east. That's how you decide. So in order for the sun to rise in the east, then the poles have to be flipped for Venus. So that's the convention. And I expect that when we start exploring other planets, quote unquote, we'll use that same convention. So it's sort of a locked in as a rule now that the sun rises in the east. Yeah, great question.
Stephen's saying that's really neat about the apparent rotation from the sun's point of view. In Kim Stanley Robinson's 2312, he imagines people who walk Mercury's terminator line as it apparently has a speed that is roughly a walking speed, but this would suggest that they'd have to run sometimes.
They could have a snooze for sometimes and they'd have to run sometimes. Yes. That is true.
So they need running shoes.
All right, let's talk about a few more things here. Was that it?
That's it.
Okay, we'll see if we got to leave time for our finest NGC at the end. So let's do a little bit more. Obviously, both Venus and Mercury vary in illuminated phase. Mercury varies from an almost full disk, about 4.5 arc seconds in diameter. I'll just zoom in here on Mercury for tonight. That'll occur. So Mercury will appear fully illuminated on the before and after superior conjunction when it's farther than the sun. So the sun is illuminating the whole Earth-facing hemisphere of the planet. Obviously, we have a lot of difficulty seeing a planet when it's that close to the sun. There are some ways of doing it, which we can talk about here in a little bit. Same with Venus. But when the planet is between Earth and the sun and heading towards conjunction, then most of the planet is illuminated from beyond on the far side away from us. So we're seeing a very slim crescent as it's approaching inferior conjunction. At the elongations, though, we're getting the half illuminated planet, as you can see here. So we've got basically half illuminated. Now, the date on which the planet appears half illuminated is not exactly necessarily the same date as the elongation. That's also true of Venus. There's about a week difference, I think, between Venus's 50% illumination and its true elongation date. And that's because the planet isn't literally at 90 degrees from the sun in space. It's actually off to the side, but a bit closer to us than the sun is. So you'd have to think about the geometry there. Let's see. If you want to see the phases of Mercury, we're seeing Mercury when it's lower in the sky. So we're viewing it through lots of atmosphere. Even in this case here, you can see Stellarium says that I'm viewing Mercury at the moment through almost 5.5 air masses. So much more thickness of atmosphere. So it would never look as crisp as this in your telescope. And by the way, if you're using a telescope or binoculars on Venus or Mercury, the sun has got to be below the horizon. That's the rule we use for eye safety for everyone. There are exceptions. We can talk about those in a couple minutes, but that's the basic safety rule. So because Mercury is fairly low in the sky, after sunset or before sunrise, you're often going to see it dancing a lot to your eyepiece. Lots of blurry, lots of artifacts in the software. For best results, though, you want a nicely well collimated telescope. You're going to need to magnify Mercury a fair bit to get a good view of it. I think the rule of thumb is about 2x or 2 power per millimeter. So a 100 millimeter telescope would give you, say, 200 power maximum magnification would be about the most you'd want to use. Mercury's visual brightness varies a lot. It varies from about magnitude minus 1.9 at superior conjunction down to below the limit of visibility, so +6 at inferior conjunction. The planet usually in the sky, it looks like a white color. If it's low in the sky, you might get some tint. You might get some sort of rosy reddish tint when it's lower in the sky, just the way everything else does. And one thing that Venus does that Mercury doesn't do is a phenomenon called greatest illuminated extent. So I'll come back to that in a little bit. A couple other things about looking at Mercury. The moon is going to occult Mercury in the morning daylight on October 14th. That'll be visible in parts of the world, not from Canada, but the coast of Brazil over to Southern Africa. It's going to be nicely posed with the moon on June 16th. And then April 20th, it's going to be with Mars. So Mars is actually being carried west by the motion of Earth, and Mars is going to encounter Venus, and then it's going to encounter Mercury deep into the summer, August 17th. And on December 14th, Venus will occult Mercury. Let's see, Venus will occult Mercury on December 3rd of 2133. So put that in your calendars for your descendants to keep tabs on. Let's see, a couple more things about looking at Mercury. You want to choose, ideally, the nights around greatest elongation. You need a site with an unobstructed view close to the horizon. No clouds, no haze. If you're viewing the planet in evening, try to find it in a telescope. You want to see it as soon as you can spot it when it's higher in the sky and then clearer. And then, of course, if you want to, if it seems like it's bloated, you can try a neutral density filter to dim it a little bit and see the shape a little bit better. Also, I understand that viewing Mercury in the morning can give you a sharper view because the air tends to be steadier in the morning as well. Okay, so last point, this actually works for Venus and Mercury. So when I mentioned Antoniadi making his map of Mercury, he was actually looking at Mercury in the daytime when it was high in the sky. And that way he was not viewing it through so much atmosphere. It's very tricky. It's for advanced observers only. It involves, using a solar filter on your telescope to focus your telescope, keeping your telescope properly filtered until you've slewed to the planet, then being careful that no sunlight is actually entering the front end of the telescope. You can actually use a shroud to extend the length of your OTA to doubly ensure that. And then the last thing is when you think you've got your telescope on Mercury, you want to uncap the eyepiece and wave your hand over the eyepiece to make sure there's no sunlight coming through. You do all of that before you would ever look with your eyes. And people have been able to do it, but it's, again, it's not recommended. And if you want to try it, find an experienced observer or a RASC that's practiced at doing it, and maybe see if they can kind of help you with that as well. So, yeah. So it's a theory, possible, but not recommended unless you really know what you're doing. All right, a couple more things here. Let's talk about Venus just to wrap up. So again, Venus alternates between morning and evening appearances every 584 days or 1.6 years. And the apparitions are asymmetrical. So Venus will appear and take about 8 months to reach greatest eastern elongation in the evening, and then only 2.5 months to dive back down. So it's unbalanced in that sense. In the morning, it's the reverse. So it'll take 2.5 months to reach greatest western elongation, and then a long, lengthy 8 months to sink back down again. It can vary from magnitude minus 4.9 to minus 3.8. You can even see your shadow from Venus if you're in a dark place with no other artificial lights. Again, people have viewed it in the daytime. You can see Venus a speck in the daytime if you know where to find it. Sometimes I like to mention in my skylights when the moon is near Venus in the sky, and you can use the moon as a reference to find it. And since the Venus gets much further from the sun, it's far less risky to search for Venus. Again, if you want to use binoculars, if you've got children, parental supervision is very important with binoculars up in the sky in daytime. Let's see. Some people have actually had luck using an ultraviolet filter to see some details in Venus's clouds. So that's something you could give a try too. And a couple other things. So Venus has been shining already since the beginning of the year. It's going to reach its greatest elongation on June the 4th. It'll be 45 degrees away from the sun on June 4th. By the way, if you're out tonight looking at Mercury, don't forget that Venus is going to be parked beside the Pleiades. There have been a few people on social media already posting photographs of Venus near the Pleiades. Venus actually wanders right through the Pleiades every now and again. So that'll happen in a few more years, I think. Greatest illuminated extent. So there's a night when the combination of the size of the planet and the phase of the planet causes it to absolutely peak in brightness. And that doesn't happen at its greatest elongation. This year, it's going to happen in July. I'll show you July 7th. Let's do July 7th here. And just do this. So that's the night of the year when Venus will peak out at magnitude minus 4.69. And it'll be about 26% illuminated. Just the combination of its nearness and its phase makes it brightest on that night. Venus is going to pass solar conjunction in August, and then it'll join the morning sky for the autumn. Let's see, we've got the crescent moon's going to join it on April 22nd and 23rd, and on June 30th. So let me just wind back a few days here. June 30th. Then that's the night that Mars and Venus will approach to within about 3.5 degrees of one another in the sky. They won't kiss the way Venus and Jupiter did on March 1st, I guess. But Venus and Mars will get relatively close for a while. So that's about it. I know that's a lot, a bit scattered, but hopefully you're inspired to get out and take a look at them.
Linda has asked, did the ancients construct any objects to capture the planets besides those to capture the sun? Yes. There are some archaeoastronomical sites out there where they are tracking Venus for sure.
Yes, great. Glad you could take that one. Anybody else? Just going to turn off some of these markings here. Yeah.
Atul was asking if you can see both Venus and Mercury with binoculars, and you absolutely can.
Yes. You can make out that Venus has a shape to it in your binoculars. I doubt you could do that with Mercury, but definitely I've been able to detect that Venus isn't round in binoculars. That's another great idea to try. Good. Anybody else? Last call?
I should mention that the ancients weren't sure exactly what they were looking at. They saw Venus, but they called it the star, morning star, or the evening star.
Yes, yes. Well, that concept of a transit must have been fascinating to see that and realize what was going on. I don't know if the viewers have been lucky enough to see a transit in Mercury, but if you can watch it through your telescope, just as it's ingressing or egressing from the sun, your brain really, really tells you that you're looking at a three-dimensional solar system in action. It's I just noted that when I was looking at it. I just was really impressed.
I'll see if I can find a picture of the Mercury transit that we saw here on the Sunshine Coast and share it with everyone. Also, someone's asking you, Chris, what sparked your interest in astronomy? Your enthusiasm is contagious.
I don't know. I don't think everybody's born with the bug. I got the bug. I was born with it as long as I can remember. I do have an astronomy book that my grandmother gave me when I was about 8, but I must have already expressed an interest by that point, so she knew to give me the book. But sometimes it's an event like that. People see Saturn, or somebody gives them a book that enchants them. I think I just have the gene for it. I don't know. What about you, Charles?
Sorry, I was looking for that photo. Well, I saw Saturn for the first time back when I first got my 3-inch refractor telescope that my parents gave me, and that was was about 10 years old, and I've been looking at stuff in the sky ever since.
Nice. All right, let's do the finest NGC corner, and then we can, if we have time at the end, we can take some more questions. Let me just set this up. So as you may recall from last time, I mentioned that the list of finest NGC objects compiled and put in the Observer's Handbook by Alan Dyer and the folks that make the handbook is heavily weighted towards the springtime objects, just because there's so many cool galaxies to see during springtime. And as a result of that extra long set of objects, then it means we're going to have to cover a bigger number than we have been typically doing with the other times of the year. And because they're all relatively dim objects, it's not really possible to time it against the moon the way we typically did when we had, you know, open star clusters and other objects. So I'm just basically going to take the finest NGC objects for spring, start with the most westerly ones, and then every session we do kind of march further and further to the east as they sort of come to center stage in the sky. The other twist on that, though, is that you'll notice that when you go out of an evening, you know, the objects that are quite northerly in declination, so the ones that are kind of up near Ursa Major, that sort of thing, they're already very high in the sky right after dusk. Whereas some of the other objects that are more southerly, they need their time to cross the meridian and culminate at a higher elevation, which is when you really want to see them. So I've actually been kind of ordering these by my suggested kind of order of approach on an evening, starting with the most northerly one and then sort of waiting for the more southerly declination ones to culminate. So here's the set we've got for this week. And again, we're not saying that this is the only week to see them. We're just sort of suggesting, you know, this is the next batch to take a look at. The sky is going to get dark around 9:30 local time these days. So if you're out there ready to go at say 9:30 to 10:30, 11-ish, you'll have ideal conditions to be picking these ones up. So first up, we've got NGC 3344 up here above the back of Leo the Lion. Let me just do the north up again. This is the Sliced Onion Galaxy. And again, it's one of these really pretty, gorgeous, but relatively faint face-on spiral galaxy. It's visible in any size of a good telescope in a dark sky. It's got a stubby bar. You can't really see. There you go. I can see the stubby bar here when I zoom in a little bit. It's got kind of a stubby bar. It's got a bit of a ring around the middle of it. And then it's got these nicely spaced arms that wrap around. And those arms have nice little knots of H2 star-forming regions that you might be able to pick up if you've got a good-sized telescope in really, really dark skies. This one was discovered by William Herschel on April 6, 1785, so just a couple of days ago, last week. It's located actually in Leo Minor. So there's Leo Minor sitting above Leo, but it's kind of makes a triangle above and between Zosma and Algieba. So that's a great way to kind of get your finder scope in roughly the right spot. Use a low power eyepiece and just aim that. I had a line from Denebula through Zosma. So if you kind of do this, there's another way of doing it. So make a line through these two stars and almost double that. And that points right in the right direction. So the combination of that kind of vector plus the triangle should get you in the neighborhood that you need. There actually is kind of a triangle of medium bright stars here. I don't know if you can see them, 40 and 41 Leo Minoris, and then 54 Leonis sitting here. But if you can see these in your binoculars, then you could also just aim your finder midway between 40 and 41 and pick it up that way. Use averted vision, try different magnifications because, it seems that you can see different aspects of a galaxy by working it at different magnifications. You want to see the characteristics of its core, of its spiral arms. It's got some interesting field stars superimposed on it, so you can check those out as well. This one's about 20 million light years away. All right, next up, we've got the Hamburger Galaxy, which is part of the Leo triplet, NGC 3628. So this one is relatively easy to find. If you've looked at the Leo triplet before, which is Messier 65 and 66 and another galaxy, NGC 3628 is the other galaxy. And so if you know where to find the Leo triplet, you're already good to go. What you can do is reference Denebula and Churton and kind of get yourself in that neighborhood. It's only really, I think it's about 2 degrees below Churton or south of Churton if you aim your finder that way. This is a large kind of edge-on spiral galaxy. I'm just going to turn off the labels here so you can see it a little bit better. It's got a bisecting dust lane, which is sort of the meat of the hamburger, if you think of it that way. It's actually not as easy to see as the other two spirals, the two Messier spirals with it. But a medium aperture telescope or one a bit larger will show it nicely under the dark skies. Discovered by William Herschel on April 8th of 1784. Don't over magnify it too much. So try checking it out with a bit of a lower magnification first. Use that averted vision again. You want to note the field stars around it. You want to tease out the interesting shape of the halo because it's not your normal shape to a galaxy. And see how it looks compared to the dust lane, you know, how the center of the galaxy is distributed around the dust. And do you think you see the core? That's another question that you could raise. It's about 25 million light years away. Up next, we've got MGC 3344. Whoop, that's the one we already been. Yeah, 3384. Sorry, 3384. Here we go. So this one is kind of conveniently located just below and between the midpoint of Churton and Regulus, underneath the stomach of the line. This is a relatively bright lenticular galaxy. It's in the same high power magnification field with Messier 105 and NGC 3389. So it's kind of another triplet in Leo. And in fact, if you zoom out a little bit, there's also M95 and M96. So this whole group will actually fit together at low power in a telescope field of view. Now, the three Messier galaxies, the 105, 96, and 95, they're a bit brighter. So, but once you see those, then you need to use your skills to look a little bit to the northeast for the other galaxy as well. So, averted vision will help again. Again, you want to magnify it as conditions permit. You want to note the characteristics of the core, the shape, the orientation. And if you've got a bigger aperture telescope, you can start to see how far you can sort of extend the halo around it. This one's about 26 million light years away. Let's see what's next. Next up, we've got NGC 3607, which is up here in the hindquarters of the Lion. And again, if you've got your triangle of Denebola, Zosima, and Churton figured out, then it's relatively easy to aim your finder just a little distance to the east of and a little bit above the midpoint between Churton and Zosima. There's no stellarium image for this one, so I'll bring up the alternate view here. So this is a lenticular, possibly an elliptical galaxy. It shares the eyepiece with some other galaxies in the neighborhood. Leo's full of galaxies, as the whole region is. There we go. I'll bring up some numbers for you here. This should be visible in a 4-inch or larger aperture telescope, discovered by William Herschel back on March 14th of 1784. It's located about half a degree east of that line joining Zosima and Churton. And you can search with lower power and then zoom in as needed. Use averted vision. You want to note its shape, its companion galaxies, whether you can make those out, and note any field stars that might make little patterns, like there's a neat little asterism right beside it. This galaxy, interestingly, is known to have globular clusters, which have been imaged. So that's kind of cool. It's about 70 million light years away, which is a long distance. All right, now we've got NGC 3521 heading down. So I call this part of Leo the lion's den, because in binoculars, you can kind of make out these medium bright stars in a big sort of circle, and it's down amongst those, or inside the, just inside the den of the lion. And this one is a real showpiece. It's called the Bubble Galaxy. Just zoom in a little bit. So it's really pretty. It's kind of reminiscent of the lion's tongue 2903 that we talked about last time. It's a relatively bright and large, slightly barred spiral galaxy. It's highly inclined, which improves its brightness, making it bright enough for large binoculars and any size of a telescope. And again, it's inherently brighter than lots of the Messier objects. Discovered by William Herschel on February 22nd of 1784. It was his number 13 in his class 1 objects. And as I said, it's in that ring of 5th magnitude stars. So if you can sort of pick up, P4, P5, P2, P1, and 55 Leonis, and also especially P3, then all you need to do is aim your telescope a little bit to the east of those. Let me just bring up the field of view, and I'm just going to drop the eyepiece. Oops, do that one more time. Just bring that 26 millimeter eyepiece. So you can see that P3 Leonis, which is magnitude 6, will share the field of view with the galaxy. Another way you could search for it, if you can't see those, is I noted that I star hopped from Sigma Leonis, which is up here. I think that's Sigma Leonis here. I just found this star, which is bright enough to see at magnitude 4. And you could also aim your finder's scope midway between D Leo and Phi Leo. Let's see if those come in here. But yeah, that'll get yourself in the neighborhood. You want to note the shape and the orientation of the galaxy. You want to try more magnification to tease out details, especially if you have a bigger telescope. Notice that it's got some dark dust lanes in here, which will affect the overall shape you see in the eyepiece. And so check that out. Different estimates for its distance, maybe 30 to 50 million light years away. I saw different numbers there for that. Now, the last three I'm going to cover are best looked at later in the evening when they culminate, when they're higher, because they're a bit more westerly. So I'm actually going to wind the time forward to about 10 o'clock here. Let's get them a little bit higher. So first up, I've got NGC 4516 or 4517, which is way over here in Virgo. Let's bring this up here. Again, no picture in Stellarium. I'll just bring it up. This is a relatively faint edge-on spiral galaxy. It's quite lengthy, though. It's contaminated by a prominent field star, and that can kind of throw off, brightness estimates for it. Discovered by William Herschel back in February 22nd of 1784. But this one you're going to need maybe a 6-inch telescope or larger to see it well. It's located about 1 degree above. Let's see, let me get this out. There we go. About 1 degree above the midpoint of the line connecting the double star Porrima to Xania. So that's a great sort of place to aim your finder scope. And I star hopped from Porrima, and I noticed that there was a neat little kind of asterism here that kind of confirmed for me where I was. So sort of a cross shape, kind of a Cygnus little shape, mini Cygnus shaped asterism, Charles, on the way to that galaxy. There's also a galaxy NGC 4541 that you might see on your way. So you want to use averted vision, look for its shape and orientation. That field star I mentioned, there we go. It's about 40 million light years away. There's also this other faint smudge of a NGC 4517 above it. So if you've got a dark sky and a big telescope, try to get a 2-for-1 when you're looking at that one. All right, backing out a little bit. Next up, we've got the antenna or rat tail galaxies. Those are down here in Corvus. So let me just bring these up here. This is also known as Caldwell 60 for those British list fans. This one is cool. It's a little bit hard to see though, because it's quite low in the sky for Canadians. This is a spectacular pair of interacting or colliding galaxies discovered by William Herschel back on February 7th of 1785. It's actually been given 2 Caldwell numbers since there's 2 galaxies in the grouping. They're readily seen in smaller telescopes under dark skies at lower latitudes, not necessarily from Canada. From here, you're going to need a 4-inch or a 6-inch or bigger telescope to see it, because they don't culminate very high in the sky for us. They're close to the spot where you can double the line from Algorab through Gienah, double that line, and they'll be close to that spot. And the 5th magnitude star 31 CRT or crater eye, I'm not sure the Latin for that, is just below it, just south of it, 0.8 degrees south of it. So again, you want to use your averted vision. try to see the shape they make. You'll need a big telescope and good conditions to see the rat tails, the antennas, but you might be able to pick those up. I think the northerly one is a bit brighter than the southerly. You're going to note the field stars as a kind of a triangle of field stars here. And just again, experiment with different magnifications to see what you can tease out. They're about 73 million light years away. And last up, we've got NGC 4361, which is over here. In the upper half, this is sort of central to the upper half of Corvus. This is an outstanding planetary nebula. It's actually larger and brighter than the Ring Nebula is. And it would be more popular if it weren't so southerly in declination, because it doesn't get very high for us in Canada. It was discovered by William Herschel on February 7th of 1785. It was number 65 in his class 1. And as I said, it forms an equilateral triangle kind of below Algorab or south of Algorab and Genaya, so you can pick it up. You could relatively easily aim your finder at that spot. I actually noted kind of a Big Dipper shape, or kind of a Dipper-ish shape, maybe Pleiades shaped asterism just below it, as confirmation while you're kind of hunting. Because it's a planetary nebula, you can pop in an oxygen 3 filter or a UHC filter and brighten it up with respect to the rest of the stars. So that'll help you to zoom in on which one it is. And to see its shape, you want to use nice and high magnification and start teasing out, the shape of it, but maybe some structure if you've got a bigger telescope. Again, see if you can see the central star, the white dwarf star in the center. And it's about 3,900 light years away. And that's the list for this time. Any questions in any of that?
There isn't, but you know what? I found that picture I was looking for. So if you'll...
I'll stop sharing.
I will start sharing here. There you go. That black dot there, that's Mercury. That
nice.
Is transiting. That was from our observatory in the Sunshine Coast. That's Mike Bradley. He's currently our second vice president. Took that. He's a serious solar observer. So yeah, that's what it would look like. I'll stop sharing.
Thank goodness they come around more often than Venus's.
Yeah, really. The last time we tried, it was cloudy, like you said. We were all down there on the pier waiting for it to come up, and the clouds just wouldn't get out of the way. It was
too bad.
A little gap there. It looked like the sun was coming up, but it was above the clouds already. So
too bad.
Oh well.
Good. Well, I hope everybody has a chance to get out and look at the inner planets at their best, and check out some finest NGCs next week. No moon next week.
Yeah. We'll
Perfect
see
chance.
you all next time for some more of this.
All right. Well, take care, everybody. Keep looking up.
Keep looking up, everybody.